I do believe we are live. I am here because I have been studying Boot.dev. I got motivated by some of their marketing, where they offered a Resolute badge if you study every day in January, as well as a chance to win a Boots plushie if you gather enough experience. So here I am gathering experience. What do I see up there? Okay, everything seems to be working. I have over here a terminal that I'll be using to edit code and run Pygame. And I have over here a web browser with the Boot.dev website. Now that I have all of that, oh, and down here I have a keyboard viewer that will show you what key presses I'm using on my keyboard, which I thought might be interesting since I'll be using NeoVim. So you can see, for example, how I navigate around my text files using keyboard presses. With that, let's build Asteroids using Python and Pygame. Build an Asteroids game. We're going to build a simple video game based on the classic Asteroids. Speaking of games, Boot.dev has a number of gamification features that have, over the past few days, effectively tricked me into spending more time learning on their platform. One of those features is to buy and activate a potion so that I can get more experience for completing lessons. So that's nice. Anyway, Asteroids. If you've never played before, you can take a look at this slightly different from our version of the game. And here's a preview window. Prerequisites. Python 3.10 installed. I have that. I did the bookbot project as well. The UV project / package manager. I have that. Access to a Unix-like shell, example Z shell or bash. I have Z shell here running in Ghosty with some Oh My Z shell customization. So basically Z shell is how it will work. Learning goals. The learning goals of this project are as follows. 1, to introduce you to multi-file Python projects. 2, to get you used to refactoring documentation. To get you used to referencing documentation. Okay, sure. Something you'll do often in the real world. 3, to show you a real-world use case for object-oriented programming. 4, to have a ton of fun building a rewarding project. The goal is not to teach game development or the math required for physics simulations. As a result, there are some places where you'll simply copy-paste code that we wrote for you. Don't worry about trying to understand every detail. If it's not interesting to you, you will be asked to write the parts that matter most. Assignment to get started, make sure you have the Boot.dev CLI installed and working. I do. Run and submit the CLI tests. Here we go. I copy this. Boot.dev. I have Boot.dev installed on my machine. And it's going to run this code, which represents the lesson that I'm currently learning. So, Command V to paste, Enter to go. And this was sort of a trial run of this lesson. Over here it says that it's running, echo Boot.dev CLI is ready, expect an exit code of 0, it gets that. Expect standard out to contain all of Boot.dev CLI is ready, check. Running UV version, expect exit code 0, check. Expect standard out to contain all of quote UV, check. So I'm ready to now do the submit version of this. I copy here I paste here, I hit enter. All text pass, and both of my screens light up. How nice is that? Oh, and look, I've earned a sharpshooter chest. Thanks, Boot.dev. Open chest. I get 2 gems and 1 baked salmon. I'll maybe mention later what those do. On to the next lesson. We're going to be using Pygame and a virtual environment to develop our game. Pygame. Pygame is a module for developing games using Python. It provides simple functions and methods for us to draw images within a GUI window and handle user input. Notice, unfortunately, Pygame doesn't yet support Python 3.14. Until it's updated, we recommend using Python 3.13. Make sure it's installed before continuing. We'll come to that in a moment. Virtual environment. Virtual environments are Python's way to keep dependencies, e.g. the Pygame module, separate from other projects on our machine. For example, we need Pygame version 2 for this project, but another project on your computer might require version 1. As a best practice, each Python project on your machine should have its own virtual environment to keep them isolated from each other. Create a new assignment. 1. Create a new UV project on your computer. Before I do that, I'm going to go ahead and UV Python install the, what number did they say? 3.13. It quickly downloads that. They have everything prepared. And now I have a UV managed Python 3.13.2 on my computer. Let's see, I could copy this, but I'll do the typing. UV, we're in the code directory, that's good. UV init, I'm simply going to call this Asteroids. And as the instructions say, cd into your project name, cd Asteroids. Enter. We're now in the Asteroids directory on my computer. My shell, or my shell configuration, oh my Z shell, has inserted some information about Git that I'll ignore for now. And so I'll continue on bravely to 2. Pin your project's Python version to 3.13. I'll also go over here and click off the ones I've done. So UV Python pin 3.13. Now we have pinned .python version, which is actually a file that UV created for me. File that UV created for me. Knock that off. Hey, we got a chatter. Asks, what are you doing? Hey, bro. Hey, I am learning or relearning some game dev stuff with Boot.dev and Pygame, following the instructions on the Boot.dev website. Next. 3. Create a virtual environment at the top level of your project directory. So we do UV venv, enter. Using CPython 3.13.2, that's good because I pinned it to 3.13 before. Did that. Activate the virtual environment. Type source.venv/bin/activate. Go. It adds a little hint here to tell me that we have that. Activate the virtual environment, check. You should see your project name at the beginning of your terminal prompt. For example, mine is Asteroids, Wags Lane at MacBook Pro 2 Asteroids. We do. Make sure that your virtual environment is activated when running the game or using the Boot.dev CLI. 3. Why did I say 3? That's odd. 5. Add the Pygame library as a project dependency. We go UV add Pygame double equals 2.6.1. Enter. And it's going to do some work. That was pretty quick. This tells Python that this project requires Pygame with an exact version of 2.6.1. Did that? 6. Make sure Pygame is installed. UV run -m Pygame. Wonder why we're using UV run, and I wonder if that automatically respects the environment here, or if it selects an environment according to some UV configuration. Do not know. We'll do this anyway. Okay, UV run -m Pygame. It's taking a moment. What's it doing? This will result in an error. The test expects an execute of 1, but the output will show that Pygame is installed. Is UV like installing Pygame under the hood right now? What's happening? The fact that that took so long implies to me that it was setting up a separate virtual environment under the hood. I'm guessing if I ran it again, it would not go so slowly, but first let me actually read the output. Pygame 2.6.1 details. Hello from the Pygame community. Good. Directories. No module named pygame.main. Pygame is a package and cannot be directly executed. Fair enough, yeah. It wants... there is no Pygame main, because Pygame is a package that you're expected to import into your own main function. That makes sense. But on the other hand, why did that take so long? I'm assuming it's because UV run set up a whole separate infrastructure. But let's just rerun this and see if I'm correct, then it should be super speedy this time. Boom. Okay, yeah. I think UV run built an automatic environment in the background somewhere, which is distinct from the environment that we created for the project, which is interesting. Anyway, that's that. Do the test run of the Boot.dev evaluator. Expecting execute 1, check. Expecting standard out contain all of Pygame 2.6, check. Python 3, somewhere in here, check. Hello from the Pygame community. Okay, we can do this for real. And ta-da, it works good. Notice something about Weasel. I'm not using Weasel because I'm not on Windows right now. Hello from the Pygame community. Okay, Pygame. Now that we have Pygame installed, let's write just a bit of boilerplate code so that we have a runnable program to build on. Assignment, open main.py. It should have been created when you ran UV init. Okay, I'm going to open main.py, and I'm choosing to do this with NeoVim, specifically LazyVim, which is a configuration setup for NeoVim. Let's open NeoVim. It's not behaving very well right now. That's annoying, but I'm just going to move forward. It's not sitting in the window nicely. That's going to annoy me, but I think it's better just to move forward. Okay, open main.py. It should have been created when you read UV init. It was. Check. On the first line, import the Pygame module. This will allow us to use the Pygame library in this file. So, with some Vim trickery, if I do Shift-O, I open a new line above, import Pygame. Right, it's complaining that Pygame is not accessed. That's okay for now. Modify the main function from the default print statement, which we have there, to something to instead print starting Asteroids with Pygame version. Where version is the version of Pygame you have installed. So let's get started with that. We can use this print statement we have here, and I'm going to use delete function. Is it a function? Is it a key? Seek to... should have done it before that. Now I'm confusing myself. Anyway. Oh, right, because that. Someone's not very good with their tools. And I used an arrow key, which is bad style in Vim, but oh well. I'm embarrassed. I'm not using Vim very effectively right now. Oh. Huh. Okay. Because we imported Pygame at the top of the file, we can now dynamically access the pygame.version.vir attribute. So let's try that. Pygame. And if I Shift K over version, we see that it's a string. So we can print that nicely in our print function. Let's write this. Side note, I kind of want to have rough in here. Nah, I won't do that now. Okay, we've done that modification. Keep the name equals main code block at the bottom of this file, if name equals made. This line ensures that the main function is called only when the file is run directly. It won't run if it's imported with a module. It's considered the Pythonic way to structure an executable program in Python. Yep, we'll do that. We WQ from NeoVim. Huh. I would like to know where they put the Python executable that UV run controls. I'm just going to make a note to myself with an echo command right now. Later, find out where UV run puts its installation of Python and dependencies. Use the correct end quote, and boom. Okay. Starting Asteroids with Pygame version, and it's 2.6.1. That seems correct. Now we run the tests. Starting Asteroids 2.6.1. Expect standard out to contain all of. Starting Asteroids, got it, and 2.6.1. Got it, good. Sweet, that one's done. Modules. It would be a massive pain if we had to fit all our code into a single file. So, let's organize our code into separate modules. Since each .py file is a module, we can group related functions, variables, and classes together in a module. Then other modules can import them using the syntax from module name import my function. From module name import my function. Or import everything from module name import star. I don't want to import star. Constants. Games often have a lot of magic numbers to represent things like player speeds, item costs, and attack damage. We'll use a dedicated module as a place to store these kinds of constant values. Assignment. Okay, whatever. Assignment. Create a new file in your project called constants.py in the same folder as main.py and paste this in. So we're going to go nvim constants.py. Give it a moment to load up. And if I click to copy it here, and then I use the key P here, it should, yep, print those out. Write that. That's done. Next, import the screen width and screen height from the constants.py file into main.py. So we'll go to the Explorer, open up main.py. from constants import. And the nice thing about this editor is if I type capital S here, it knows from context to go look inside of constants and autofill for me. I actually want to start with width, so I'll type a W, and it finds the W in there, and I hit enter, and it gives me screen width, which is nice. Anyway, comma, screen height, got it. Okay. Now let's go normal mode. After the starting asteroids message, also print out the screen width and screen height values when main.py is run using the format below. Let's jump down 4 and tab insert, which puts spaces in the file in my configuration. Okay, we can just I'll make a message string here. Make an F string. Screen width colon braces. I almost typed 1280. That's not exactly the point. This is width. A new line into screen height colon braces screen height and the quote and print the message. Okay, we wrote both of our changes. Let's actually make a new tab here for this. It opens by default in the same directory, which is useful. Run Boot.dev. We're missing a space here. So control tab over here. Try that again. Up arrow is a shortcut giving me the last command in my shell. Screen height 720. 720, got it. Expect standard out to contain all of screen width, screen height. Yeah. Wait, what? Oh, cat constants.py. Yeah, that's a different one. Check that I got my spacing right. Yes. Okay, so we can run-s this. You've earned a daily quest chest. Neat. Open chest. Gems. Baked salmons. Potion. Excellent. Game loop. Modules. Okay, we did the modules thing. Locking game state. We're about to use Pygame to open a GUI window and draw things to it. That'll be fun, but how can we verify that the game logic is working correctly? How indeed. To make this easier for you, we provided you a logging function, which you just need to import and call in one place. It takes a snapshot of your game state about once per second for up to 16 seconds. Okay, that's smart. Only log a certain amount of time of game time for up to 16 seconds or until the game exits. These snapshots will be saved to a file called jasonstate.jsonl in the JSON lines format. Our Boot.dev CLA will use the logs to ensure your game is working correctly. Neat. Game developers use logging like this all the time for debugging and testing. Assignment. For now, just add the logging code to a file. We'll have you import and call it in the next lesson. Create a new file named logger.py, touch logger.py, in the same directory as your main.py file. Paste in the code from the logging code block below and save the file. Sure. nvim logger.py. Oh wait, I was going to do neovim in the other terminal, so we'll just quit that. Control tab, Explorer. There already is a, oops, we're just gonna quit without saving changes, start again. Okay, sometimes I get lost in neovim and think I'm doing one thing, but it does something else, and it's often best to just quit and start over. Reset that context. Yeah, I'm in logger.py. That's where I want to be. Create the file. Paste the code from the logging code block below. Where's the logging block below? Logging code. Here we go. Oh, it's sort of a lot of stuff. Sort of a whole lot of stuff. Okay, I didn't read all of that, but I trust Boot.dev enough to blindly paste this into Python. So we write that file. Just to check that that worked, I'll do head on logger.py. We got some stuff. That's good. For now, just add the logging code to a file. We'll have you import and call it in the next lesson. Create a new file named logger.py. We did that. Add gamestate.jsonl to your .getignore file. Just to make it quick, I'll use vim here. Vim.getignore. And I'll make a comment because, yeah. Add game state.jsonl to make sure your logs don't get committed to your repository. That's a good check. Let's see if we have JQ. JQ. Not found. All right, we'll have to install that. Install JQ on Mac OS with Homebrew. So JQ, here we go. Just let that run a little bit. Okay, that's fine. Run and submit the CLI tests. This one. See if that works. A lot of stuff. What was it? What was it checking? Expected to contain all of, yeah, that stuff that's from before. Cat logger.py. Expecting standard out contain all of stuff that we put in logger.py. That makes sense. And JQ version. Expecting standard out to contain all of JQ-1. Yeah, it's all there. So we can now scroll back up. Boot.dev run. Ta-da! Moving forward. Game loop. Video games are generally built using a game loop. The simplest game loop has 3 steps. 1. Check for player inputs. 2. Update the game world. 3. Draw the game to the screen. To create a good user experience, these steps need to happen many times per second. Assignment. Let's go to, what file are we in here? We're in logger.py. We can just close this. What's this? Let's go to the Explorer. Oops. Okay, we're going to main.py. Within the main.py, initialize Pygame using the pygame.init function at the beginning of your program. Within the main function, though. So, let's go up 4 lines. O to open a new line. Wait. We need to, up here, from logger, import log state. Oops. Within the main function, initialize Pygame using the pygame.init function. Up above, it's complaining that log state is not accessed. That's fine for now. Okay, did that, did that. Use Pygame's display.setMode function to get a new instance of GUI window. Should I do that above or below? I have a feeling we're going to end up commenting. Well, it makes more sense to me to do this generic printing stuff before. So, oops, I kind of messed that up. We did pygame.init. Okay, I'm back with you. Use Pygame's display.setMode. No. Pygame.display.setMode. That's good. Set mode to get a new instance of GUI window, and on the instructions it says screen equals. We'll get to screen in a moment. Pygame.display.setMode paren double paren, so we can start a tuple. Screen width, comma, screen height. Close the parens. I know there is a hotkey in NeoVim to go to the beginning of the line, but after indentation. But I don't know what it is, so let's do it that way. Screen equals that. So we have created the screen. Now we can see the game. This is good. 4. Create the game loop. For now, we'll only worry about step 3 from the list above, drawing the game to the screen. We're in insert mode. 1. Use an infinite while loop, so that'll be while true. For the game loop, at each iteration, it should call the log state, no arguments needed. I'm a little curious what is inside of log state, but I'll leave that mystery unresolved for now. Use the screens, so screen.fill method. To fill the screen with a solid black color, you can literally just pass the string black to the method. And my editor helpfully tells me that the first argument here, first parameter here, is color, which is a color value, which apparently is smart enough to handle being a string name of a color. So we just filled the screen with black pixels. Good start. Use Pygame's display.flip method to refresh the screen. Be sure to call this last. Interesting. So you put stuff on the screen and then you call display.flip Pygame, so it's going to be pygame.display.flip. Function definition flip parens arrow none. So it returns nothing, but presumably it will have side effects like drawing things to your screen. Lot state is not defined. How did I end up getting, lot, yeah, okay. Seek T, select G, replace that T with a G. And now it's a lot happier. Write that out. So let's check these. Let's check that we did these. Log state, done. Use the screen's fill method, done. Use Pygame's display.flip method, done. Did that, did that. Run and test your game frequently as you write your code to make sure it's working as expected. For now, you should see a black window open and stay open. Interesting, so we're not handling the quit condition. Although I assume you can override that just by like clicking close in the window that opens. So let's try this out. Go back to this terminal, uv run main.py. Oh, interestingly, okay, wait, where's my window? Do I have a window? Not sure I have a window. Also something else I'm thinking about, but where's this? Python 3, where'd it go? I don't see it. Huh. You know, I wonder if there's a... Okay, the application is not responding. There's some problems here. For one thing, I forgot to activate the virtual environment, and I wonder if that changes how uv run main.py acts. The fact that when I interrupted it, it was apparently on display.flip implies that it was doing stuff, but I didn't see anything, so oops. Let's try it again. uv run main.py. Please open a window for me. Something may be misconfigured. We'll deal with that later if we have to. Run and test your game frequently. Okay, yeah. For now, you should see a black window open and stay open. Out of curiosity, if I run Python in the virtual environment, which was created by UV, and do main.py this way, is that going to be a different behavior? I do have Python running on my system, but I'm not seeing the window, so may need to do some troubleshooting. Somewhat annoying. Out of curiosity, is it populating the log? I would like to see the log. So let's open another window. Wait, what was the log thing going to be called? Somewhere I had to do a git ignore that would tell me the name of the log. Here it is. GameState.jsonl. That's the one I'm looking for here. So it's cat game. See if it, yeah. The timestamp, elapsed, frame, screen size. Okay. It is doing stuff. That's good. But I'm not seeing stuff. That's not so good. May have to troubleshoot that. Close the game and kill the program with Control-Z in the terminal. Not the close button in the window, but I didn't see the window. Why didn't I see the window? Add the following code near the top of the game loop just after the log state call. This will check if the user has closed the window and exit the game loop if they do. It will make the Windows close button actually work. This is what I was mentioning before about that, where should we put this? Oh, it's got to be in the game loop. So for near the top of the game loop. Oops. After the log state call. So that's where we want to put it. So for event in pygame.event.get. I need a oops. Okay, for event, if event.type equal to game.quit, colon, return. That brings us out of the loop, which is good. So we write that. Did that. 7, 8. Make a git commit. It's a good idea to commit your progress whenever you get something new working. Except that right now I don't have something working because I can't see the darn window for some reason. Oh, Chatter says hello, sir. Hello, Chatter. I will make a git commit. That's a good idea. Let's see what we've got. Whole bunch of stuff. I might want to commit some of the setup files separately from the game code content. So to that end, let's git add uv.lock and pyproject.toml and not main.py and not logger.py and not constants.py, but yes readme.md, which I didn't even realize that it created, but okay. Yes.python version and yes.gitignore. UV setup files. Actually, I should do something a little better than that. Initial commit colon UV setup files. Okay, good enough. And now we've got our .py files, and I want all of them committed. So git add dot start game logic. Good enough. Okay, we've done our commit. Very good. And mode of commentary. What if we look back at .gitignore? Gitignore includes games.jsonl. And if we ls game star, we'll see that there is in fact a gamestate.jsonl file, but it was not committed to Git. Meanwhile, a chatter says, "Sir, please, can you help me get an internship?" I think Boot.dev can help you more than I can, but if you have some general questions, I can maybe help with that. Make a git commit. Done. After running the program for a bit, then closing it, check that you have a non-empty gamestate.jsonl. Oh, I did that, but don't edit it manually. It'd be kind of fun to just go in and add some trash so the tests here fail. Anyway, most of the assignments for the remainder of this project will be tested against the log file. We're going to UV run again. Hey, this time it worked? Why? What changed? Like, what gives? Why didn't it work before and why does it work now? It's the classic. My code's not working and I don't know why. Later, my code's working and I don't know why. Beautiful. Just beautiful. And look, when I closed the window, it kind of feels like adding that quit logic made it able to run. But that implies that, hold on now. We can exit this terminal. Get over here. If I just go to select a few lines, GC to comment, write that, UV run main.py. Is it like gonna, I'll be darned. It's almost like there's a static code analyzer that stops me Huh. It... Huh. It's almost... Okay. Side note, check later. Does Pygame require quit logic to be allowed to show window on Mac OS? Question mark. We can just come back to that later. Although I want, like... I also wonder, like, if... Let's just put in a static false comparison. 1 equal 2, print hello. Would that allow it to run? Apparently not. Now let's... Oops. Now we can, Curious. Was it that it was... Okay, let's undo that. Try something else. Import time. Let's jump down to 12. Oops. Time that sleep is this seconds, so we'll go 0. I don't know, 2. If there's if it takes long enough, if I throw in just a wait, does that allow it to run? No. Huh. Just really wants that. Just really wants that sleep time in there. I mean, not sleep time. It really wants that quit check in there. Because now if I uv run main.py, it just shows me the game window. Huh. That is rather interesting. Okay. After running the program for a bit, then closing it, check that you have a non-empty game state.jsnl. Head game state.jsnl. Let's take a look at that. How many lines of head does it give me? Time stop 22:06. Looks like it's local time. Elapsed 1. What does elapsed mean? Elapsed second. Frame 160, 120, 180, 240. Seems like a lot of frames are... Huh. So is that... Are we running at 420 frames per second? Possibly. We'll look into it later. Okay. Run this thing. What is this going to do? Oh, it's just analyzing the text in game state.jsnl, expecting it to find 1280 and 720, which were what? The screen size gets logged on every call to log. Sure. Redundant, but I guess it works. Okay. Let's run that. All tests passed. We gained some XP. Nice. Frames per second. I was just wondering about frames per second, and now the course is going to teach me about frames per second. Very good. FPS. As it stands, our game is redrawing the screen as fast as it possibly can. This causes it to use a lot more CPU than it actually needs. Makes sense. Delta time. The Greek letter delta is often used to represent a change in a value in mathematics. In game development, we use delta time to represent the amount of time that has passed since the last frame was drawn. This value is useful to decouple the game's speed from the speed at which it's being drawn to the screen. If your computer CPU speeds up, its speed is not constant like a sprinter running as fast as they can. The asteroids shouldn't also speed up. Imagine developing games if you had to, if the game would run for the player at a different speed on a different CPU. Madness. Conversely, if your computer slows down, the asteroids shouldn't also slow down. They may just move less smoothly. Assignment. FPS stands for frames per second. We're going to restrict our game to draw a maximum of 60 times per second or 60 FPS. 1. After initializing Pygame, but before the game loop starts, create, okay, we got here. We're in, are we in main.py? I think we're in main. Yeah, because I imported time to add some silly waiting. So let's go to 8. Oops. Yeah. Delete that line. Okay. Now up here are after initializing Pygame. After initializing Pygame. But before the game loop starts, so before 7. Oops. Create a new clock object using pygame.time.clock. I guess we'll just call it clock. Sure. Clock equal pygame.time. Is that a capital C? Dot clock. There we go. Is clock a function? It's a class. So, okay. Use parentheses to call the constructor of the class so that we can have a clock, an instance of a clock. Over here, if I shift K it, it's a clock. Okay. Chatter says hi. Hey, or says hey. Hey, Chatter, welcome. Okay. That was clock. We created a clock. We have a clock. A new clock object using Pygame.time to clock. 2. A DT variable set to 0. DT equal 0. After initializing Pygame, before the game loop starts. Okay, we've done those two things. Boom. Chatter asks, is your channel monetized? No, this channel is not monetized right now. 0. 2. At the end of each iteration of the game loop, call the .tick method at the end of each iteration of the game loop. Now, because we're in NeoVim, there's definitely some fancy way to jump to the end of a scope, which would take me like to line 6 or 7. Oh no, 6, 7. You're welcome. Anyway, jump down. Except that wasn't line 6 or line 7. That was just 6 or 7 lines below the current line. Relative line numbers. They're a thing. At the end of each iteration of the game loop, call the .tick method on the clock object. Clock.tick method. And pass it 60. It will pause the game loop until 1/60th of a second has passed. Let's look at the context hint here. You feed to tick a frame rate. That's convenient. So boom, 60. So 60 times per second. Okay. It will pause the game loop until 1/60th of a second has passed. Unless I did something silly like on the line above, sleep for 1/50 of a second. But I'm not going to do that. The .tick method also returns the amount of time that passed since the last time it was called, the delta time. Divide the return value by 1000 to convert from milliseconds to seconds and save it to the DT variable we created earlier. We have a dt variable, so we can say that dt now equals this divided by 1000. And yeah, what I'm going to do is jump to here and append a .0 on that so that my editor considers that to be a float, which will be the result of this division here would also be a float. So for type consistency, that's why I added that 0.0 there. It says dt is not accessed. Right, yeah, right now we're only setting it. At the end we did that, and we saved it to dt. Print, I guess we can print it. Print the updated dt value to the console. Seems a little messy, but we can delete it later. Felt cute, might delete. Print dt. Yes. Rerun the game. Okay. If you run main.py. Look at it printing. It's just printing away. Let's stop all that printing. That's a lot of printing. You should still see the same black screen, but this time it should use less of your system's resources. It's good, I guess. As far as I know, it didn't interrupt the stream before, so that's good. Okay. You should also see the dt value printed over and over to the console. It may even fluctuate a bit. Yeah, we got 16 and 17. 6, 7. You're welcome. You should also see the dt value printed over and over to the console. It may even fluctuate a bit as your computer's CPU speed changes. Is it the CPU speed that determines that? Among other things. Remove the line.prints dt to the console, but leave the variable itself. We'll need it later. It creates a ton of noise. We just wanted to see it working. Yeah, I was complaining about that right away. And now my editor is complaining that dt is not accessed, but that won't stop the game from running. It's just an editor hint. Okay, we did that. If everything is still working as you'd expect, run and submit the CLI tests. Let's do UV run once again. Open it up. This time we're not constantly printing. And we are able to close the game. It's so funny that it wouldn't show the window when I didn't have quit logic. It's like a safety feature of some kind. But how does it know? Well, I mean, the source code's right there. Huh. Okay. It's expecting... What is it expecting? Whoa, it's not displaying very well. Oh well. Running JQS, quote, 2.elapsed. Some comparison, some logic based on the contents of the log. And there's a true here, so I guess I don't have to worry about how it arrived at true. It just know that it got true. So we can, woo! Nice. Sprites. In our game, asteroids are visually represented as circles, and the player, and we're on to chapter 3. Nice. Okay. Asteroids are visually represented as circles, and the player is a triangle. Triangle, circle. However, detecting collisions between circles and triangles is hard. Makes sense. To avoid this problem, we can cheat a bit. The player will secretly be a circle for the purposes of collision detection. And developer.amazon.com docs game maker hitboxes. Hurtboxes. Game maker on Amazon.com? Okay. Huh. Anyway, the red circle won't be visible in the game. We just need to know it exists. Info. Throughout this project, we will provide some code for you, like the class below. We want you to focus on OOP concepts, not the game physics. As such, we've pre-written some of the code you'll need, like the circle shape class below. Okay. Assignment. In Pygame, there's a base sprite class that represents visual objects. Let's create a circle shape, and they're just going to do that for me. Very nice of them. File, and paste in the following code. Create a new, okay. Go to Neovim, add a circle shape.py, open it up, get ready to paste in, import Pygame. So we need Pygame, and what happens if you end up importing Pygame multiple times? I think it's okay. Chatter says, hey bro. Hey, what's up? Okay, so they've done some scaffolding for me. Base class for game objects. It's a circle shape. It's a pygame.sprite.sprite. It has an init, x and y, I'll assume are the position. It has a radius that's useful. It has attribute containers. Set the position. We set it to 0 velocity at the beginning, sure. Give it a radius. Interesting that we store the xy as a Pygame object, but the radius just as a is it int? Float? Maybe? Find out. Circle shape extends the sprite class to store 3 additional attributes specific to our game. Position, x and y coordinates. Velocity, radius. And where are they linking to? Wikipedia for velocity and radius. Cool. Later, we'll write subclasses of circle shape and override the draw and update methods with the logic for each particular game object. Inheritance. Is that all I needed to do? Okay. It's complaining about containers because it's worried that it may not be defined. In fact, let's just... No, I won't. I'm just going to close that buffer. Don't need to look at it right now. The tests are going to cat circle shape.py, and it's going to expect standard out to contain all of class circle shape, etc., etc. Yep, we're good. Hey, got it. Chatter says I'm a 2D animator. 2D animator, cool. I'd imagine you're animating something more involved than circle, triangle, circle. Draw player. Let's draw a spaceship for the player. Add the following values to constants.py. So let's go to the Explorer. Now, am I in a mode where J will move down? I am. And if we go to insert mode, then I can type to find what I want. Constants.py. Got him. Oops. 3. Line 3. Assignment. Add the following values to constants.py. Caps lock. Player. Radius equal 20. Caps lock. Line width equal 2. The width of the line that draws the player ship. Okay. Write that. Create a new file. Player.py. Explorer add player.py. Need to open player.py. New file player.py with a player class that inherits from circle shape. Where did we put circle shape? Circle shape.py. A new chatter says, hello sir, what is this project about? This is, what was the title of it? The project is make an Asteroids clone using Pygame, according to a course on Boot.dev. And also earn experience and badges on Boot.dev, because the gamification has hooked me nicely. We're in insert mode in NeoVim. We are in player.py. We declare a class that's going to inherit from something, and that something is coming from circle something. What was it? Circle shape.py. From circle shape, import circle shape. Bam. Now we can inherit from circle shape. Good. So 1 and 2 steps are done. The player constructor should take x and y as integers as input then. So Tara asks, for backend, should I prefer Flask and Django or anything else? Well, when you say Flask and Django, I don't think you would use both. You would choose one. Django is more batteries included, so probably start there. But is there a reason to use anything other than Flask or Django? Those are the only two I've heard of. I don't know of specific reasons why you would need a different one, but I'm kind of curious about that. A chatter asks, how long have you been in this industry? What is this, 2026? So I started learning coding professionally in 2019, so it's been 7 years. Although back in grad school, I did some programming for chemistry, so maybe longer. We are on class player circle shape. Call the parent class's constructor, passing in x, y, and the player radius. Okay, so we need an init method. Oh, look, I can... Wait a second. How did it know that? Oh, it's pulling... Huh, that's interesting. It's pulling in a constructor from the class it inherits from. That's how my editor knows that there should be an x and y there. I'm not going to just blindly take the suggestion. I'm going to manually write some stuff. Chatter says, thank you, sir. Love from India. You're welcome. Okay, for this constructor, def init, the player constructor should take x and y integers as input. So Selt, what? Self. That's a neat color. Self xy, not player. Oh, what did I do? Oh, yes. When your editor does something confusing, you may have committed a syntax error. In this case, I forgot a colon after the function definition. So, just add that. That's better. Y is not accessed. Are you not going to tell me that X is not accessed? Huh. Interesting. Okay, the player constructor. And now is where the parent class constructor comes in, because we do super to access the circle shape class. And we init that. And in this case, the context suggestions were actually correct because, well, I'll get into that later. Okay, anyway, where were we? Called the parent class's constructor. We just did that. Passing in x, y, and the player radius. So x from this from above, y from above, and it needs a radius of unknown type because haven't done a lot with type hinting in this project yet. That's okay. You'll need to import it from your constants. So first thing we're going to do is jump up to the top. I do not want to import all of my constants. Instead, from constants import, and we want player radius, but if I just type capital P, look at that, player radius. Enter. Very nice. Oops. 5 lines down, and we insert, and we can do player radius. So that's how we make a player. That's done. Create an attribute called rotation initialized to 0. Sure. Attribute, so self dot rotation equal to 0. You lead the Diamond Self League. Yes. See, gamification. It's encouraging. Self.rotation is 0. Got it. Paste the triangle method below into your player class. What's this going to do? Return ABC. A lot of stuff in there. All right, we'll just trust them for now. This is in the player class. That's where we are now. So if we paste, we're going to need to adjust the indentation a little bit. So visual mode 6K and shift right. And there we go. And look, we're going to need Pygame. So let's go to the top and not from, just import Pygame. And my editor is screaming. It's just screaming. Why is it doing that? Operator plus not supported for types vector 2 and float. Because the position is a vector 2. I'm guessing my editor doesn't know something that they know. Let's mark all as red. So I think I should just ignore these warnings for now. Although it is a little concerning. Self.position, which is that vector 2, and forward is the vector 2. The time self.radius is a little, I don't know. All right, we're just going to write this and close it so I don't have to look at the warnings at this time. To draw the player, override the draw method of circle shape. Okay, so we're going to have to go back to here, player. Draw the player, override the draw method of circle shape. So we define draw inside of player. I think I want it above the definition of triangle. And we define it as draw of do we need any inputs? It should take the screen object as a parameter. Yeah, I guess we would need to do that. And call pygame.drawPolygon. Pygame.drawPolygon. The screen object color, use white. A list of points, use the list returned by a call to the self.triangle. Okay. So we draw that onto the screen. Oh, a line width. So we'll need to is there a line width here? Hey, there's a line width here. Just like that. And width is right there for me, so that's good. So now I can enter line width. Okay, we did the line width, we did the list of points, we did the color, we did the screen object. Boom. 6. In your main function, so we're going to main.py. Oops. Oh, come on. 1 for main.py. In your main function, instantiate a player object. So go up here. I think we want to probably call it lowercase player equals player with auto import from player import player. Boom. That's nice. So it will have added that from player import player line at the top of my file. That's useful. Okay. You can pass these values to the constructor to spawn in the middle of the screen. Do we have a... Yes, we have. Of course we have a screen width. We defined it before. Except we need to divide by 2. By 2. Player is not accessed. We'll access it. I promise we'll access it. Lastly, we need to re-render the player on screen each frame, meaning inside our game loop. Use the player.drawScreen method we just added to do so. Draw the player after filling the screen with black, but before flipping the screen. So you set them up and you knock them down. Okay, where did we fill the screen? Screen.fill, that's 7 lines below where we are now. So 7J, oops, need to be in the program for that to work. 7J, and flipping is down a line from there, so that's good. Player.draw screen. Draw the player after filling the screen with black, but before flipping the screen. Run the game for at least a few seconds so that the log file gets populated. If everything worked, you should see a black screen with a white triangle in the middle. Progress. Run and submit the CLI test. So let's just see about this. It was UV. Run main.py. I'm wondering if it's going to crash out. Here, let's just see. Oh, it's fine. Why did my editor think it was not fine? Implicit operator overloading, maybe? Okay. I think it's been running long enough to give us something in the log. So it's tail gamestate.jsonl. We've got, oh, we get some information. So as we populate the game with a player, for example, it's going to tell us things about that player in the log. Useful. Type player, position, velocity, raid, wrote. Timestamp, elapsed seconds 14. Okay. Okay. Let's boot.dev run. What's it doing? Oh, cat. Yeah, it's going to do a bunch of stuff. Expecting it to contain type, player, and position 640, 360. Yes, it's doing that. Moving around. We want the spaceship to be able to move, but what does that mean specifically? Let's break it down. First, side quest, or side question. side quest, side question. Interesting. Do I care, or am I concerned that my editor thought that multiplying a vector times a float was a problem? I don't care that it thought it was a problem. Moving on. Okay. Moving on to moving around. We want the spaceship to be able to move, but what does that mean specifically? Let's break it down. If we press, is it going to be press or hold? We'll find out. If we press the move left key, the ship should rotate to the left, i.e. counterclockwise. If we press the move right key, the ship should rotate to the right, i.e. clockwise. If we press the move forward key, the ship should move forward. If we press the move backward key, the ship should move backwards. Left and right seem pretty similar. Let's try to write a small function to tackle those first. Okay. Create a new constant in constants.py. So we'll go to buffer 0 constants.py to represent the player's turn speed. I need to find player turn speed. I'm going to name mine player turn speed. Player turn speed equal, give it a value of 300. Write that out. Add a new rotate method to the player class. So let's go to Explorer, player.py. Man, those red squiggles are demanding attention. Can I dismiss them? Probably, but I don't know how. Operator plus. Not supported for types vector 2 and float. Well, just try to ignore it. Just try to ignore it. Create a new constant. Add a rotate method. Oops. Def rotate method to the player class. It takes one argument, dt. I told you we'd use it. I told you we'd use it. Here we are using it. Rotate of dt. What it's called, it should add player turn speed times dt to the player's current rotation. So we take the current rotation, self.rotation, and we add to it and assign it back to itself using not equal plus equal. Self.rotation plus equal player speed. Is it going to auto import, or do I already have it here? Auto import from constants. Nice. Player turn speed times dt, which we gave it to the function. Instance message to take a self. I just made a mistake. Let's read the mistake. Diagnostics 1. Self is not defined. Report under the undefined variable. Yeah, because I should have in here remembered to make the first thing there be self. So that helps clean that up. Create a new constant in constants.py to represent. Yeah, we did that. Add a rotate. Changes the player's rotation. Yes. Paste in the following update method to the player class. Def update self dt keys equals pygame.key.getPressed. If keys equal pygame.ka, so we're using ASD. So in the player class, we're going to add an update method Oh, look, it did the correct indentation of that. No, it did not do the correct indentation. What am I talking about? That's better. Now on 4 lines below my current line, it's complaining, but we'll get to that. Light bulb. If you're using a non-QWERTY keyboard, I am not doing that. I'm using a QWERTY keyboard. You may want to change the key bindings in the code to something other than WASD keys. 4. Update the missing lines to call the rotate method with the DT argument. So self.rotate, and it needs, why is it not giving me hints here? I'm confused. Because I put def update in the wrong place. Let's we need to do some V6K on indent. Now, if I go 4J, now self.rotate my editor knows things about, and that's useful. Passing through DT. To go left instead of right when pressed, you'll need to reverse DT. How can you do that? This feels like a confusing design. I mean, I get that they're going for just self.rotate minus DT. But I don't like that the name is still DT, while the meaning has kind of shifted. So I don't know about that. Anyway, update the missing lines to call rotate method with the DT argument to go left instead of right when it is pressed. You'll need to reverse DT. How can you do that? Yeah. Hook the update method into the game loop by calling it on the player object each frame before rendering. It looks like if the key is held, it'll continue having an impact. Okay. Go to main.py. Hook the update method into the game loop by calling it on the player object each frame before rendering. Let's do it above any of the screen stuff then. So player.update of DT. It needs to know DT. We can give it DT. That's fine. Done. Run the game for at least a few seconds and make sure the A and D keys rotate the player left and right respectively. Let's see if it works. Hope it works. UV run main.py. Is this backwards? It feels kind of backwards. Make sure the A and D keys rotate the player left. Nope, that's right. Yeah, we need to do something about that. It should add player speed times DT to the current player's current rotation. To go left instead of right. Oh, I see the problem. Let me just go to player it's on pressing A that it should go the other way. So seek character D, selection F, insert minus, escape, seek character D, instance F, insert delete, escape. Now, this should do just the opposite. Yep, and the response times feel about right. Okay. We done run the game. It will have put stuff in the log. I'm assuming the log resets every time you run the game. Okay, run the game. Check. Boot.dev run. True. Whatever it's checking, which I don't want to parse right now, it got the right answer. Oh, it's just looking for non-zero rotation in the player. Cool. Moving. Now we want the ship to move back and forth with W and S keys. Here we go. Assignment. Create a new constant in constants.py. So go to buffer 0 constants.py, insert, caps lock. Player, speed, 200. Write that. Add a new method to the player class called .move. Explorer, looking for player, open, okay. Go up here. Write a new method, right? Add a new method to the player class called .move. So def move of self. That connects with the dot. If you get stuck, use the reference below. This method takes one argument dt. It will modify the player's position using the following math. Start with a unit vector move. We're not checking at this time. I assume we will check later. Start with a unit vector. How did we make vectors before? Is there something in here for vector? Pygame.vector2. Okay. Pygame.vector2, that's good. Where x is a string or a float or a sequence of float or a vector equal to 0. What? Can I just give it a tuple of a sequence of float? Can I just give it a tuple of 0, 0? Will that work? Whoa, what's happening? Unit vector equals that. And okay, my editor thinks that it is a vector, so that's good. Rotate the vector by the player's rotation. Okay, we can dot rotate a vector. That's good. Dot rotate, and I assume it's going to be speed times et, right? Oh, we start with the okay. Oh, why did I put an underscore there? That's weird. Multiply the vector by, this is where my editor might get upset again. I'm going to call this scaled rotated vector because that's what I feel like calling it, equals the rotated vector times player speed times dt. And I'm curious now, variable type unknown. I'm pretty sure it's a vector. This is a vector. I think when I multiply a vector times whatever these things are, which is a literal 200, would it help if I made that a float? Huh. And this one, oh, dt is unknown. Well, we can fix that. Go find a t, that one. This is maybe outside of scope to worry about type hints, but float. Now seek to an e, that one. Huh, now it knows that a vector times a float is a vector. Why didn't it know that before? Whatever. 4. Add the vector to the player's position to move them. So self.position plus equals, is it that simple? The scaled rotated vector. I think that's all there is to it. What's it complaining about? Something with triangle. I think that's okay. Unit vector, rotate, scale, move. 3. Go to the buffer 4. Wait, modify the update method in player class. Okay, we're in the right file for that. Looking for update. There we go. To call the move method, when the W or S key is pressed. Remember to negate dt for the S key so the player moves backwards. If oh, we have keys from above. That's good. So if keys, apparently keys is a dictionary. Let's look into this. Seek to key, J, variable, keys, ooh, scan code wrapper. This is a rabbit hole I'm not going down today. Okay, keys, Pygame dot, how did it do it above? Capital K underscore A. So we just do capital A underscore, it was a lowercase w. What happens if I shift K on this? Variable, it's an int. Anyway, just trust that that works. Self.move dt. If keys. Does this mean that I can have both keys pressed and effectively go nowhere? I think that's what this means. Pygame.key underscore S key. Self.move with negate dt. Again, not wild about feeding in negative dt. Run the game for at least a few seconds. You should now be able to fly around the screen with W, A, S, and D keys. Let's try this. UV run main.py. So, something is not wired up correctly because I do not see the thing moving. What did I miss? Ah, I see the problem. Do you see the problem? The problem is my unit vector is a 0 vector. So, oops. Need to replace this 0 with a 1. I said replace the 0 with a 1. There we go. Now, try again. This would be great for parallel parking. All right? I'm assuming I did the rotation wrong somehow. Thanks for the fire emoji in chat. I appreciate that. It goes sideways. Beautiful. Okay. Is there a... Did I miss... Oh. Okay. I would have saved some time if I had just copy-pasted their code. But then I wouldn't have made these amusing mistakes. So. Okay. They want a 0, 1 vector. I have a 1, 0 vector. That's a different rotation. Hence the problem. Replace 1 with 0. Seek 0. Replace 0 with 1. Write out. And UV run main. Go forward. Yes. Rotate. Oh, and it can even drive in circles. That's pretty good. Okay. And back up. Beep, beep, beep. Okay. This is good. This is working. Now let's run this. I'm guessing it'll give me a true... Oh, I haven't been committing in a while. I should probably do that. So where are we? Get status. We've modified constants in main. We've added circle shape and player. Let's get all of these. Get commit -m implement motion and rotation. Gotcha. Okay. And we can do the submit step now. Got some XP. Hey, let's pop another potion so we can have bonus experience. Groups. Okay, cool. Now, groups. We're manually calling .update and .draw on the player object at the moment, which means our game loop is going to get more and more cluttered as we add additional objects to the game. Fortunately, Pygame has a solution. The group class is a container that holds and manages multiple game objects. We can organize our objects into various groups to track them more easily. We can think of them as a sort of Venn diagram. Yeah, Wikipedia. Okay. An object can be in multiple groups at the same time. Eventually, our game's groups will look something like this. Updatable. Well, there's a lot of stuff. Asteroid field is updatable, but it's not anything else. The player is drawable. The asteroid is in asteroids. And the asteroid is in drawable. The shots iron shot, drawable, asteroids. I get that we will draw the drawables. I'm not sure what the other groups are for. Examples of using groups. Create a new empty group called mygroup. Mygroup equals pygame.sprite.group. So you store the group as a variable. And the group lives under sprite. Add all future instances of a player class to two different groups, group A and group B. Player is the name of the class, not an instance of it. This must be done before any player objects are created. Player.containers equal group A, group B. You can iterate over objects in a group just like any other collection in Python. For thing in group, thing that do something, some value, sure. You may also call the .update method for every member of a group by calling it on the group itself. That's convenient. Group.updateDT. And it'll go and call that .update on the members of the group. Gotcha. Assignment. Before the game loop starts, so we're going into main. Am I in main right now? No, I'm in player. Go to main.py. Before the game loop starts, so go there. Before the game loop starts. Create two new empty groups in main.py. Updatable. This will hold all the objects that can be updated. Drawable. This will hold all the objects that can be drawn. Where did updatable fit in this? Oh, updatable was out here. Asteroid field is updatable but not drawable? What does that mean? We'll figure it out. Create new empty groups in main.py. Now to create a group, it showed us here, mygroup equals pygame.sprite.group. The group constructor with no arguments. Okay. And it said, what? Create two new empty groups in main.py. Updatable. So we'll make a variable updatable equal to. How did it do that? Pygame.sprite.group. Okay. Oops. And the other one is drawable. Oops. Drawable equal to pygame.sprite.group. Here we have the groups updatable and drawable. Add the player class to the updatable and drawable groups before the player object instance is created. Now, where did I create the player? I did it up there, so we'll need to move that a little bit. Cut that out. Go down 2. Paste that in. I didn't do it with much finesse, so my indentation is a little messed up. That's better. Add the player class to the updatable and drawable groups before the player object instance is created. So player class dot containers equal, that's an interesting pattern. I'm pretty sure we didn't define a containers attribute in the player class, although we did do something funky with a constructor to see if a container was there, so it kind of did something. Anyway, equals tuple of updatable, comma, drawable, boom. Diagnostics. Cannot assign to attribute containers for class type player. Attribute containers is unknown. I mean, you can tell me that I can't assign that, but I think I can. So, whatever. Add the, yeah, okay. Update the game loop to use the new groups instead of the player object directly. Call the .update method on the updatable group. So, oops. You go to here. Just comment that out. Updatable dot. Now, why does it know that update is the thing it can do? Did that come from Pygame or did that come from analysis of my source? I don't know. Call the .update method on the updatable group. Now it says loop over all drawables and draw them individually. Why? Why not drawable.draw directly? Maybe they just want to show that you can do it either way. Like, for example, if you wanted to customize the draw logic. No. For, what am I going to call it? Because it said drawable. Is a collection. This is kind of silly, but let's just say for one drawable in drawable. Now it says unknown. I won't worry about that for now. Does draw need anything? Well, my editor wouldn't know because I haven't given any hints about what one drawable is. So whatever. Run the game for at least a few seconds. It should look and behave the same as before, but now we're using groups to manage our objects. Echo note to self y update dot draw but iterate over May look into that later. Run the game for at least a few seconds. It should look and behave the same as before, but now we're using groups to match our objects. So let's run it and see if it does in fact behave as before. No. No, it does not. Because update, missing one required positional argument dt. Let's give it that. Line 12 is the one I want to go to. And dt we have, right? Yeah. Errors. Draw, missing one required positional argument, screen. Yeah, okay, let's give it that. And everything works. Whee! Okay. Back to coding. We are having fun, are we not? Okay. Yeah. So we did the group stuff. We did run the game for at least a few seconds. I think we did. Let's tail game state.jsnl. Timestamp. 10 seconds. That's at least a few seconds. Check. Okay. Boot.dev run it. True. It does some tests. And where are we on get status? I think all we did was implement groups. So use Pygame groups. That'll keep things cleaner as we go forward, I believe. Okay. Just do that. Run. Test failed. Uh-oh. Armor used. Dang. Which one is not true? Ah, dang. I do think I have a lot of armor, though. So, yeah, 12 armor. That's good. That updatable.count. Running JQ-S. What does JQ do anyway? Let's check in that. Command line JSON processor. Huh. JQ can transform JSON in various ways by selecting, iterating, reducing, and otherwise mangling JSON documents. For instance, running the command JQ map.price add will take an array of JSON objects as input and return the sum of their price fields. Oh. Okay, yeah, pipe it to add. Huh. Interesting. Anyway, it's expecting JQ-S quote dot bracket 0 dot updatable dot count greater than 0. JSON-L. So did I forget to like put things in the updatable group? Drawable is good, but updatable seems to be a problem. Add the player class to the updatable and drawable groups. So I did that. Did I typo it? Let's see. Oh. Sure did. There is a typo. So. Yeah, that's my problem. The auto creator was expecting me to have used updatable spelled UPDATABLE, and I had a different spelling. And 10 lines down, grab that E and make it go away. Boom. Okay. Now we run again and move the thing around. It's driving around. It's working. And test these. Expect true, true. Expect true, true. Yeah. Now that I fixed my spelling error, we're good. All tests passed. Yes. How many chapters are there? We're on the last chapter. Huh. How many lessons? 7. Okay. Hey, we got a chatter. Hello, chatter. Welcome. Welcome in, Mr. Chatter. Good to see you. Okay. Critical part of Asteroids is the, well, Asteroids. Let's create another class to represent them. Asteroids in our game are simply circles. Create a new class, Asteroids, in a new file called asteroid.py. I'm going to create the file here, and I'm going to be thoughtful about spelling asteroid.py. There. And Explorer, give me, oh, slash gives me there. Yeah, makes sense. Open asteroid.py. Create a new class called asteroid. Asteroid.py. Yeah, okay, we're making a class. Insert class. This asteroid that inherits from circle. Now this is cool because, okay, circle shape is there, and my editor prompts me to auto import it. Boom. Now 3 lines above we have from circle shape import circle shape, and now asteroid inherits from circle shape, and my editor and Python know what's going on. And welcome in, Odd. Good to have you here. Class asteroid circle shape. What am I doing with this class? Give it a constructor def init with this signature, and my editor is clever and gives me these suggestions, which I will accept. Give it a constructor with this signature, but what do I do in the constructor? Because my editor wants to call the superclass constructor, and we'll just leave it that way for now. And then override the draw method, so we define draw to draw the asteroid. I think draw needs DT. Let's check on that. Oops. Do we have, let's go to the Explorer and look for, what am I looking for? Circle shape.py. Oops. Circle shape.py. And I wanted to know about I think I was curious about the draw method, I guess. So draw of self and screen. Okay, yeah, draw needs a screen. That's true. So, right, draw doesn't need a DT. Draw just needs to draw. Okay, this is looking better. Override the draw method to draw the asteroid using the pygame.draw.circle function. Pygame.draw.circle. And why is it? Ah, yes, I have not imported Pygame. So we go to line 0, we import Pygame. Not Pygames. Pygame. Now we get some hints. Okay. The surface to draw on the screen object, so that'll be screen, which we have here. Color value, white. Center. Its own position as the center. Center, which is a coordinate. What is a coordinate in Pygame? I'm hoping I can just give it a vector 2. 2 of self.x, comma self.y. Its own radius. Do we have a self.radius? We do. The width of the line to draw the circle. Use line width from constants.py. Okay, line width with an auto import. Boom. And it just works. It just works. I hope. We'll see. Okay. Override the update method so that it moves in a straight line at constant speed. Each frame it should add. Okay, override the update method. Let's take a look at the update method from circle shape. Do we have, oops, do we have circle shape open? No. So go to circle shape.py. I want to know about the update method. Self and DT. Okay. Pygame. What? Right, new method. Def of self DT. Hold on, was it giving me hints there? Def update of self and DT. Except I'm not interested in using the old version. We're going to make a new version. Override the update method so that it moves a straight line. On each frame, it should add self.velocity times DT to its position. Get self.velocity from its parent class, circle shape. Huh, that's interesting. Does super call the class or the instance? First, let's look at how velocity. Wait, does circle shape have a velocity? Self dot position. Self dot velocity. It has a velocity. Oh. Do I not need to do anything special to access that? Do I just self dot velocity it? My editor thinks so. Yeah. Yeah, that makes sense. Cool. And I'm assuming self.position is in here somewhere. Self.position plus equals self.velocity times dt. What are you complaining about on 3 lines above? Oops. Attribute y is unknown. Oh, I should probably be doing position, not x and y, huh? So if I go back to here, self.position is pygame.vector2 of xy. Okay, okay. So this whole thing here is just going to be self dot. Oh, do we not even need the vector? Yes, because position is a vector, okay? Sure. Thanks, editor. You helped me there. Huh. Okay. Where are we? Asteroid.py. Give it the constructor. Override the draw method. Override the update method. So we're back to here. No, circle shape? No, we're in. We need asteroid.py. That's here. Self.position plus equals self.velocity times dt. That's good. That is good. That's what we want. Override the update. Yeah. So when it said get self.velocity from its parent class circle shape, that was just a reminder. I didn't have to do anything special to do that. It was the standard self.velocity. Okay, I got a little off track there for a second, but we got this. 5. In main.py, before the game loop starts, create a new empty pygame.sprite.group for the asteroids. What do we call it? I think we just call it... Do we call it asteroid or asteroids? Because before we were not using the plural to make the name. Okay, 2 main.py. Create a new... before the game loop starts. So that'll be up here. Let's actually go a little further up so that we're making our groups all in the same place. This time I'll try calling it asteroids equals sprite.group. Yes. Now, create a new empty pygame.sprite.group for the asteroids. Yes. I guess you could probably feed an iterable or sequence, either way, or both. Anyway, you could feed like items into the group to make them in the group, probably. But we're doing it a different way. Create a new empty for the asteroids, like we do with the player class. So let's do this. Set the static containers field of the asteroid class. So asteroid auto import. We're gonna have to import it. We imported it. Good. Containers. I know my editor is gonna complain about this, but I'm gonna allow that. Asteroid.containers. Set the static containers field of the asteroid class to the new asteroids group, as well as the updatable and drawable groups. You know what? This time I'm going to copy paste because I don't want typos. So we just get those, drop them in there. And Lazy Vim thinks I can't assign containers in this way, but I think I can. So, 7. Add the following constants to constants.py. Probably not going to type all these. Okay. Do we have constants.py open? Yes. So just drop those in there. This is an asteroid minimum radius, a asteroid kinds, 3 asteroid kinds. Asteroid spawn rate seconds 0.8, asteroid max radius, asteroid min radius times asteroid kinds. Oh, okay. So 20, 40, 60 is what they're going to be. Neat. 8. I've written an asteroid field class for you. It contains logic for spawning new asteroids. Create a new file called asteroidfield.py and paste in this code. I'm gonna be a little bit fancy here and use a command pasteboard paste into asteroid field dot py. So make that new. And now if we go looking for, we've got all this stuff. Import Pygame, import random, from asteroid, import asteroid, from constants, import star. I don't love that, but they're all in caps and stuff, so I don't think we'll make mistakes. Edges equal, so we get the edges of the screen. And then init pygame.sprite.init. Interesting. Spawn update. Okay, so the spawn timer counts up with DT. And the spawn timer can reset. Spawn a new asteroid at a random edge. Oh, they come from the edges. Random.choice from the edges, sure. Speed, random.randint, yes. Velocity, edge 0, so that must give the direction somehow. Kind, randomize the kind. Spawn it according to a method that we defined above. And that's it. Okay. There was some complaint in there, but not going to worry about that now. PV paste, asteroid field.py. Yeah, we did that. Okay. Thanks for writing all that code. That's good stuff. Now, in the main file, import the asteroid field class. Did I already do that? I feel like I did. Set its static containers field. Oh, asteroid field. I'm confused between asteroids and asteroid fields. Okay. Asteroid field auto import. Boom. Set its static containers field dot containers equal only the updatable group. It's not drawable and it's not an asteroid itself. But do I do this as a one-member tuple or do I do it as just the thing? Let's try doing it just the thing. I don't know what type containers is supposed to be. We'll just try this. After adding the container, create a new asteroid field object. Asteroid field. Create. And I don't think I need to give it anything there. Asteroid field equals that. I don't know if I'm actually going to end up using this variable, but we'll see. After adding the container, create a new asteroid field object. Run the game for at least a few seconds to make sure that asteroids are spawning and moving across the screen and that you didn't break your ship in the process. Here's hoping. UV run main.py. So we can. No, it's not. It's not doing the asteroid thing. Now, my first thought is if we put that in there as a one-member tuple, does that make the difference? No. No, it does not. So, rather than trying to debug the code, I'm going to review the instructions and see if I've forgotten something. Asteroid that inherits from circle shape. Give it a constructor with this signature. Did I do something wrong with the constructor? It's possible. Override the draw method. There could be a problem with drawing the asteroid. It might just be, in fact, let's just tail game state.jsonl and see if we have some asteroids. Type, asteroid, position, blah, blah, blah. Okay, we've got lots of asteroids. What's RAD? Anyway, the point is there are many asteroids in the game, according to the log. So, my suspicion falls upon draw. Asteroid.containers includes drawables. So that's not the problem. But if we go to definition of asteroids and draw, Pygame.draw circle, screen white, This all seems good. Did I forget to trigger the drawables? Okay, this is kind of hacky, but print draw me. Uh-huh. So something's being drawn at least. And that something has to be an asteroid because I inserted the print method in the draw method of the asteroid class. Okay. F string with self dot position colon brace self dot position. Are the positions funny? No, the positions seem okay. Yeah, the positions occasionally they go negative, but it looks like they get cleaned up afterwards. For one drawable in drawable, one drawable dot draw with screen. And in this case, Pygame dot draw circle. Surface, surface, color, center, radius. Did I mess up the radius? Self.radius. Let's check the radius. Now we're getting... interestingly, we're only getting radius of 40. Is that reproducible? 40, 60. Okay, we're getting different radiuses, so that's not it. So game state does know. What is the... where's the timestamp here? Sprites, asteroid field, type... 1280 by 720. Position 13. That's off screen. Is that a problem? Asteroid 105. Well, this one should be on screen. Velocity, radius is 60. I feel like I should see these things. They appear to be moving. What about this? Before the game loop starts, create a new empty pipe for the asteroids. Did I typo again? No, it seems okay. Like you do with the player class, set the static containers field of the asteroid class to the new asteroids group. Oh, wait. Class as well as the updatable and drawable groups. Oh yeah, we did that. Updatable and drawable. We can copy paste it to get it right. This ensures every instance of the asteroids class is automatically added to these groups upon creation. Add the constants. Use the written thing. After adding the container, create a new asteroid field object. Asteroids are not spawning. They're just not spawning. Not visually, anyway. Yuck. Any helpers in chat? Anyone know why I am not seeing asteroids? It seems like I should. Let's double check that I have the correct content in my file asteroid field.py. Oops. Ends with self.spawn. Yeah. Is it relying on some behavior in the asteroid class that I've gotten wrong? Let's check on that idea. It did tell me to give it a constructor class with this signature, self xy. Wait a second. Did I get ahead of myself by... What if I just... Could that be it? Huh. Let's also comment out those prints for now. Let's inspect the provided code in the place where it spawns an asteroid. Ah. Wait. XY radius. But here it's radius. Okay, but let's look at spawn. Spawn. Self radius position velocity. Asteroid equal asteroid of position.x, position.y, radius. Asteroid.velocity equals velocity. Now what I had done here was call super init. So let's look at circle shape. This init does what I would think it should do with... Oh. Circle shape constructor sets the velocity to 0. That may be breaking something. 4K. So let's just hand roll the equals, what was it? Self-top position is that, and radius is just like that. No. Radius. Let's do a quick test now. Still not showing me the things that I want to be seeing. I guess setting the zero velocity might not matter, because this is going to control. Yeah, that would have overwritten, so that doesn't matter. But I guess it's cool that I did it this way. Also, time to commit. Work in progress, add asteroid field. So what is different between player, which we see, and asteroids, which we do not? I'm a little bit suspicious of this asteroids group. We have updatables and drawables. And asteroids. Are asteroids supposed to be handled some way differently? After adding, did I just do that backwards? On the game for at least a few seconds, make sure the asteroids are spawning and moving across the screen and that your ship didn't break it. The ship's not broken, but the asteroids are not spawning. In the main.py file, import the asteroid field class and set its static containers field to only the updatable group. After adding the container, create a new asteroid field object. Run the game for at least a few. Let's check that these imports make sense. Yeah. One thing I want to try is do drawable group of unknown dot draw the screen. I'm kind of annoyed if this works. Oof. No, that's not the way. But if that change broke something, then something's happening that... Something's happening that I don't quite understand. Okay. I see why we didn't do it this way. Calling draw here reroutes it to surface.bl blitz on spr.image, but we don't have an image. That's an interesting behavior. I see now why we didn't do that. For interest, let's go at every frame and have a counter and increment that counter, and here print with that counter. I should actually like say what it is of drawables. There's the problem. But I thought it was calling the... Okay, drawable. Let's go up. Asteroid containers includes drawable. Was one drawable the wrong name? That shouldn't matter. Is drawable printable? Let's try that. Group one sprites. Does that mean that... Now wait, I thought that we were... At some point I thought we were effectively... What should I say? At some point I thought we were calling that draw function, but maybe not. The player is getting updates and the player is getting drawn. This is silly, but I'm going to do it. I'll replace... Oops, that's not the right kind of... too drawable. Yeah. Can you tell I'm running out of ideas when I try something like that? I think asteroids should be in the drawable, right? Wait, this time... This time we actually aren't... Let's let it run a bit more. And... Timestamps. Updatable, count 2 sprites. Asteroid field, type player. Drawable, count 1 sprites, type player. Asteroids, count 0. Huh. Now I'm confused in a different way. All right, let's do some more print statement debugging. Also, let's get rid of those. And asteroid field is where I want to be. And let's see if spawn asteroid is getting called. That's happening. Now if we tail, asteroids are not wired together somehow. Oops. What did I just do? Player.containers, asteroid.containers. Wait, maybe... Huh. Go to main.py. What's happening up here? Oh, okay. Seems like we're failing to add. Where are we now anyway? Why are we not drawing asteroids? Pattern off an asteroid. I don't know how they're doing this. Let's close this. Yeah, it might be time to call it for this session. I don't know what I've done wrong. The weird thing is, for a while I was having asteroids. Wait. That's interesting. Anyway. Am I doing something in the wrong order? We made the groups. Now let's look at the constructor for asteroid. No, I should be using the super. Because that has logic to init with containers. So now it's sort of trying to draw the stuff. Let's do this. Let's go to main.py and just after all those drawable calls, let's paste in this pygame.draw on screen. And self-deposition is going to come from an asteroid at 100, 100, with a radius of 20. The thingy is that. Thingy dot position. So we also need seek to SD and insert oops, what did I just do? I don't know what I just did. Hopefully nothing. Import constants to do delete me. I made a window up here that I don't want. I don't know how to get rid of it, so let's just quit. Whoa. Asteroid field.py, sure. Go back to NeoVim, find file. Main.py. Okay. UV run main.py. No, we don't even see that one. Huh. So, circle onto a surface, which will be screen, into a color value, which will be white, into a center coordinate, thingy.position might be the problem here. Let's just use a... Whoa, something just went weird. Oh, that's annoying. Send me back to my Firefox. Why would it do that? That was weird. I think there's a problem with the way I'm using position. Oops. Yeah, there's something wrong with this draw. Why do we not know what position is? Oops. Oh, we can't. Yeah, we... Oh, boy. What did I just do? I guess I'll do... Hold on just a second. Okay. Center, tuple, int, or float, or interfloat, or list, or vector 2. Okay, so let's look at this, shall we? We have all this drawing stuff. Oops. From line 38, we updatable set update. That's fine. That's actually fine. But one line down, we do a bunch of draw stuff. Then, down here, we do a bunch of draw stuff. Then, down here, we screen.fill black. Oops, that just washed out everything we did. Then, down here, we draw the player. That made me think everything's still working. Then we, yeah, okay. Ugh. Put draw methods here. So, oops. Let's, yeah, okay. Not a problem. Need to relocate draw calls. Oops. There we go. Now, we're just going to go up a bit. Go up a bit more. Oops. Okay. Just cut out all that. Go down here. Drop those in there. Take out some of this debugger stuff, but not all of it. Now let's also grep for draw me. I'll put draw methods here. That's interesting. Anyway, this is the one where I want to comment that. Main.py. Yeah, to do put draw methods here. So, we did that. Now, uv run main.py. Wait, what? That's kind of cool. It's not right. That's kind of neat. Like, you know. Well, okay. Fun. Why did I... Code is structurally unreachable. Screen.fill black. Yes. So, we just... My pasting was a little bit without nuance. I accidentally over-indented the screen.fill black so that it was structurally unreachable. That's why the screen wasn't resetting to black every time. That's why it didn't look right. Here we go. Ah, yes, okay. So if I had been a little more thoughtful of where I put my draw method into the main function, this would have gone a little quicker. Good to know. Okay. Don't need to write again, but whatever. We do need to... Let's... Asteroids do appear. Now let's just take out this extra stuff. We do not want player.drawScreen because that should be handled elsewhere. Wait, why is screen fill black before the updatables? That doesn't make sense. I wish I was better at doing this. You know, maybe I shouldn't say player as a variable. So our game loop is as such. While true, log state, check for quit, update the updatables, fill the screen with black, draw the drawables. Let's change this name. You know what? Let's do that a little smarter. Is it space CR? Yes. Change it to a drawable. Yes. Okay. Now all this stuff goes. Wait, does that all go away? Thingy. Draw the. Yeah, that all goes away. And I'm gonna update, draw, tick. Yes. Okay. Let's UV run main.py. And for now, we can drive through the asteroids if we really want to. Is there any? There's no limit to going off the edges. Whee! Okay, fun. That's enough. Right. So, yeah. Run the game for at least a few seconds, making sure the asteroids are responding and moving across the screen, and that you didn't break your ship in the process. Yeah, we're good. Tail game state.jsnl. Where is the? We got a number of asteroids here now. Where's the timestamp? Timestamp. 14 seconds. Okay. Okay. Run the Boot.dev run. Expect true, true. Expect true, true. Neat. Okay, we got that one. Collisions. You may have noticed that you can. Try again. Collisions. You may have noticed that you can fly through asteroids without any consequences. We need collision detection. Now, this is a fairly deep topic, but we're going to keep things simple. We'll treat everything, including our triangular ship, as a circle when it comes to collisions. Detecting a collision between two circles is simple. Calculate the distance between the center of the two circles. Distance. Calculate the radius of each circle. Calculate. We already know the radius of the circle. Anyway, R1 and R2. If distance is less than or equal to R1 plus R2, the circles are colliding. If not, they aren't. Nice and simple. Assignment. Everything that collides inherits from circle shape, including the player, which we're kind of pretending is a circle, right? So that seems like a good place to write our collision logic. So circle shape. Let's, close some things and then explore. 2. Circle shape. Open it. Okay. Add a collide with of self and other method to circle shape to check for collisions. Where do I want to put it? Probably down here. Init, draw, update. Let's put it here. Def collides with of self and other method to circle shape to check for collisions. It should take a circle shape as parameter, aside from self, of course, and return true or false. Light bulb. Each circle shape has a position property. That is a Pygame.2 vector. You can use positions distance 2 method. Oh, that's convenient. Distance 2 method to get the distance between two shapes. Then use that distance to decide whether to return true or false. Okay, so we take self dot position dot distance squared to. That's an interesting method. Distance 2 other dot position. So that's going to give us a distance. And they were calling it just distance above, so we'll do that here. So now, and then we, let's do R1 and R2 equals self dot radius. Boom. R2 equals other dot radius. Return the condition. They are colliding if distance, how did they write it above? Just do it how they did it. If distance is less than or equal to R1 plus R2. Less than or equal to. Wait a second. Is that okay that it made like a special symbol there? Huh. Here's hoping. I haven't seen that before in Python source code. Seems okay. Back in your main file, import the log event function from the logger module. Oh. Huh. Explorer, main, let's go. Oh, to do delete me. Yeah, delete that. Log state, comma, log event. 3. Add gameEvents.jsonl to your game events. Oh, okay. Get ignore game events.jsonl. Cool. After the update step in your game loop, so we need main. Down a few. After the update, iterate over all the objects in your asteroids group. For asteroid in asteroids, check if any of them collide with a player. Okay. Can we, I guess it doesn't matter which way we draw from, but asteroids dot. Oh. It's not asteroid dot. Why didn't it? Def collides with. Oh, I think I know why. Yeah, my editor doesn't know the type. So why doesn't it know the type? Because I think I know why. Okay. Anyway. Why is it complaining about player? Player is not defined. Okay, no, he might need the player. Log event string player underscore hit print game over to the console and the game immediately with sys.exit. Don't forget to import sys. Oh, why are we not doing a Pygame quit? Huh. I guess they just want to teach us different ways of getting out of it. Start the game, run your ship into an asteroid. Different game over to your console and exit. Okay. Oops. Come on, asteroids. I want to run into you. Hey, it worked. Yes. Tail game events.jsnl. We got timestamp, elapsed seconds. It makes me want to do a speed run to game over. It's okay for asteroids to simply pass through each other for now. If that were to run and submit the CLI tests, we can mark this as red for now. I'm not going to do another quest right now. Hey, what's it doing? Huh. Game events.jsnl. We have a game events.jsnl, right? Yeah. Okay, it's just, I don't know, it got stuck somehow. Expecting true. True. Okay. It's going well. I think I might finish out the thing tonight. Hey, confetti, yeah. 1, 2, 3 shooting, 4 rate limit, 5 destruction, 6 splitting. Yeah, maybe not all of it tonight. Shooting. Let's make things more interesting by allowing players to shoot at the asteroids. What are you doing with a gun in space? In our game, bullets are small circles. Easy. Move at a constant speed in a straight line. Easy. Split up asteroids when they collide with them. Cool. Are spawned by player input, spacebar, and move in the direction the player is facing. Assignment. Add a new shot radius constant and set it to 5. Shot radius equal 5. Write that. Create a new shot class to represent a bullet in a new file, shot.py. Explore. Add shot.py. Class shot. It should also inherit from circle shape. Ah. Oops. Whoa. Whoa. What'd I do? Oh no. We're just gonna give up on those changes and start over. Okay. New file. Write. Shot.py. Bam. There's an existing shot.py? No. Nothing in it. Okay. Explorer. Okay. Class. Shot of circle. Shape. Why is it not? It should also inherit from circle shape similar to asteroid class. Don't forget to override its draw and update methods just like you did in the asteroid class. Right. Def. Let's look at asteroid. Draw of self and screen. Pygame.draw this. I need to import Pygame. Self.position, self.radius. I guess line width is going to be the same. So draw def update method self, and I think dt asteroid.py def init self update self dt. Okay. This is just that self.velocity times dt. Add a new shot radius to the oh. We don't do that there. We always make it with the shot radius from the constant. Okay. Oh, a chatter says, can you please provide me an internship? I don't have any internships to give out. Sorry. Create a new shot class. Draw and update methods. I think I need to give it a velocity. It's telling me about that stuff later. Okay. So I think we're good here. Create the shot class. Oops. Yeah, we'll have to deal with the velocity later. That's fine. Oops. One. Okay. Set up a new shots group in your main.py initialization code. This time being somewhat careful to put things in the correct order. We can delete this line because it's never going to happen. Go up, up. Equals Pygame dot group. I am not throwing away my shots. Sure. Set the containers field of the shot class. We need to import shot, but maybe it'll figure that out for me. shot auto import shot.containers equals a tuple along with the set the containers field of the shot class to include your new shots group along with the drawable and updatable containers, just like you did. Yeah. Add player shot speed to your constants file with a value of 500. Buffer 1 constants. Oops. Equals 500. Nice and quick, that. Oops. Whoa, 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 whoa. Right. Okay, caps lock is dangerous. That's what we learn here. 1 main.py. What happened if we made 2 asteroid fields? In your player class, so we need to explore to player init draw rotate move a shoot method. This method takes no parameters and does the following. No parameters. I guess it just needs to know that it's been called. Set the shots. What shot? Oh, create. Okay, yeah. Shot equals shot. Shot auto import. There we go. At X and Y. I could do fancy tuple unpacking, but meh. Can I do self-deposition.x? Is it that simple? Hopefully. Is there any other thing to do here? No. Shot equals create the shot. Create a new shot at the current position of the player. I wonder if my editor will complain about this one. Shot.velocity equals. I'm going to make a function for this. Let's make velocity. And for this we need we have Pygame, yes. A dot rotate. I don't need to put in self. Do I need to put in self? Ah, whatever. Let's do this differently. Start with a Pygame start equals Pygame dot vector 2 of 0 of tuple of 0 comma 1. Rotate it to the direction. Is it just self dot rotation? That looks right. Then player shoot player. This should be shoot player shot speed. Buffer constants. See. Okay. You know, I could have done anyway. Where was I? There we go. Yeah, okay, I need to give it the self thing. But it... Cannot access attribute of X for class onbound. It's thinking that self doesn't have a position. This is kind of messy. Let's just... Oh, no, no, no. What did I do? This is kind of messy, but let's see if it works. In your player class, handle the spacebar Pygame K space and call the shoot method when it's pressed. So this would be with update, right? Why did my screen go crazy there for a second? That was annoying. Okay. Down. If keys. Get pressed, sure. Huh. This is gonna like spam shooting for now. Okay, underscore. If keys, if that. Self dot shoot. Run your game for at least 2 seconds, then fire some shots. Make sure the bullets are being created and moving in the correct direction. Let's just quit so I make sure that everything's been written. Player shot speed. Yeah, okay. Where was that? Player.py. Updatable? Really? Main line 29. Is this main? Okay. What? $29. Is that better? Yes. Whoa, look at it go. Yeah, we need to rate limit that. Pretty nice, though. Game over. Oh. And it's typing A. Yes, very good. We should have done some stuff before, but whatever. Add bullets, but do not rate limit them. Looks cool. Neat. Info. It's expected that holding the spacebar will create a constant stream of bullets. We'll fix that soon. It's expected that bullets pass through asteroids without any consequences. We'll fix that soon, too. Okay. We're evaluating the game state log. True. Neat. Here's a trick. I can do up space dash S. Neat. For rate limit, Zerg Rush. You probably noticed that the weapon on the ship is currently as overpowered as the original Zerg Rush. Where did they send you for that? Wikipedia Rush video game. Good. Let's fix that. Assignment. Create a new variable in the player constructor. Constructor. Okay, self dot attaches a shot cooldown timer. Should I call it shot cooldown timer? Or something, I don't know, something else? Or shoot cooldown timer. Whatever, shot cooldown timer. Start with a value of 0. Okay. Constants. Do we have that open? No. I don't trust myself to type this one right, so let's just copy, paste, equal 0.3. Okay. When the player tries to shoot, this exists in player. Okay, good. When the player, well, should I do this check inside of shoot, or should I do this check on in update? When the player tries to shoot. Look at, okay, yeah. Look at the form of update. It's all about, oh, but there's some bleed over, but still. Look at the form of update. It's keys and if keys, call a function, or call a method, actually. Unfortunately, this negative here kind of breaks that, but still, I don't want to put too much more in here. I just want to call .shoot, and I want .shoot to handle the logic. Okay, decided. If, when the player tries to shoot, if the current value of the timer is greater than 0, the current value of the timer is greater than 0, if, okay. What was it called? Shot cooldown timer greater than 0. I don't know why we're doing it this way, but let's try it. Prevent the player from shooting. Just return then. Otherwise, I don't need to type an else here. It's don't need to type an else here. Otherwise, set the timer to player shoot cooldown seconds. I think I see it. This is an auto import. This is an auto import. Shot cooldown timer equals that. Wait, why are you complaining? Aha. Self dot. That's better. Every time update is called on the player, decrease the shoot timer by DT. So give me update. Does it matter whether we do that before or after? It only matters as much as the time of a single frame, which is to say it does not matter, so we'll do it at the beginning. Shot cooldown timer minus equals DT. So we just drag it down, and if it's in the negative, it's allowed to shoot. But if you shoot, then it gets placed at the cooldown in the positive, which it can't shoot. Okay, I get this now. Run your game for at least 2 seconds, shooting to your heart's content. You should now be rate limited to one shot every 0.3 seconds. UV run main.py. Hey, not as pretty, but it'll do. Game over. Sure. Rate limit the shots. Okay. Check this thing. Paste. Expecting true. Output true. Expect true. Output true. Cool. You've earned a sharpshooter chest. Well, thanks, Boot.dev. Open chest. 3, look at all those. 3 gems and 1 frozen flame. Very nice. Destruction. Okay, so bullets are fine, but they don't do anything. Let's kill some asteroids. Yes. There are 3 types of asteroids. Large, medium, and small. Yes. When a large asteroid is destroyed, it should split into 2 medium asteroids. When a medium asteroid is destroyed, it should split into 2 small asteroids. Now, this could take a bit. When a small asteroid is destroyed, it should disappear. For now, we'll just always make the asteroids disappear when they're destroyed. We'll handle splitting them later. Assignment. Add another collision group. Add another collision check to the game loop. Loop over each asteroid. And for each asteroid, loop over each shot. And I think I have groups to represent those. So, yeah. If a shot and an asteroid collide, call log event asteroid shot. Use the .kill method on both objects, the shot and the asteroid, to remove them from the game. Info. The .kill method is built-in feature of Pygame sprites. It removes the killed object from all of its groups so that the engine stops updating it and drawing it. That's good. So in main.py, add another collision check. So loop over each asteroid. Where are we doing the collision checks? Here. This is an n squared, isn't it? It's okay in this context. 4. Asteroid in. Did we have an asteroids group, so we can use that. For asteroid, no. For asteroid and asteroids. Then, for shot, and do we have shots? For shot and shots. Log event, asteroid shot. Call the kill method on both objects, the shot and the asteroid. Shot.kill. Now what does it mean that I'm nervous about killing something while it's iterating through, but we're not mutating the group that's being iterated through, so it's probably fine. Run the game for at least 3 seconds and make sure you can destroy asteroids by shooting them. If you run main.py. Whoa, where? Oh no. Oh no, what's happening? What's happening? Some logic is not correct. Yeah, oh, okay, yeah. if a shot and an asteroid collide. If asteroid collides with. Yeah, that's going to be better. Hey, what? What's going on? Huh. There we go. Aiming is kind of tricky, but it's working. Shoot asteroids. Shoot asteroids to destroy. Let's take a look at the one-line git log. Wait. Oh. Git commit amend is what I was looking for. -m. Shoot asteroids. Now we git log one line. Shoot asteroid to destroy. Close enough. I mean, technically you are only destroying one at a time, I believe. Is that true? Huh. We got true, so we can submit this. All tests passed. Just studying. This one could be interesting. In the original game of asteroids, part of the challenge comes the fact that the larger asteroids split into smaller faster. Ooh, good. Asteroids when you shoot them. Let's support that. Large asteroids split into 2 medium asteroids. Medium asteroids split into 2 small asteroids. Small asteroids disappear when destroyed. After splitting the new asteroids, the smaller move faster. After splitting the new smaller asteroids, move in new random directions. Do they conserve angular? Do they conserve momentum though? For example, in the diagram, new direction for new asteroid, original direction. New direction for new asteroid. A new angle for the new asteroid is chosen at random between 20 and 50 degrees. Then the new asteroids are created and start moving in those directions. So it's like a split. Okay. Now, instead of using asteroid.kill, your game loop will create and use an asteroid.split method. Add a .split method to the asteroid class. Okay. .split self. Immediately kills up. Think about it. This asteroid is always destroyed. Maybe we'll spawn a smaller one depending on its size. Fair. Interesting. It's nice the Pygame keeps track of the groups for us. If the radius of the asteroid is less than or equal to asteroid min radius, just return. How could it be less than? Huh. Radius less than or equal to asteroid min radius auto import. Yes, please. Just return. Otherwise, we need to spawn two new asteroids like so. Call the log event quote asteroid split quote. Be sure to, oh yeah, auto import. Now it's been imported, right? Yeah. Random.uniform. Do we have random? No. Ooh, what? Random.uniform to generate a random angle between 20 and 50. Is that inclusive? Don't care. Be sure to import the standard random library at the top of the file. Yeah, sure. Call the .rotate method on the asteroid's velocity to create a new vector representing its first equals self dot rotate angle float. Is it degrees? Here's hoping. We need to actually random angle equals that. Rotate by the random angle. First velocity equals that by rotate by negative value. Second velocity equals self velocity dot rotate, which produces minus random angle. First val, second val. Compute the new radius of the smaller asteroid using the formula old radius minus asteroid radius. Radius minus asteroid min radius. Hey, there you go. Create 2 new asteroid objects and at the current asteroid position with the new radius. How's that going to look? Huh. And to create it, you just call it. We don't actually have to track the variable because groups do that for us. Asteroid, is that an auto import? I think so. Asteroid of. The new radius, okay. Wait. So we do need to do some more stuff with it. Create 2 new asteroids. Set the first velocity equal first vel times 1.2. 1.2 is the magic number. Second asteroid, no. Second asteroid dot velocity equals second velocity run the game and shoot some asteroids. Okay. UV run main.py. Why would you put it over there? I do not understand. Ugh. There we go. Wait, why are they so little? Am I even going to manage to shoot one of the right ones? It's not doing the thing. It's just not. Why is it not doing the thing? First step, tail, game events.jsonl. We got asteroids shot. We're not getting. Okay. we're not getting the split to happen because we're not calling the split in the main function, our main module. So asteroid dot split, not an editor command. What did I do? Whatever. Sooner or later we should hit one. Hey, there we go. Pretty good. Yep, that's working. Close this. I'd kind of like it if I could type Q to quit, but whatever. Now, tail game events.jsonl, asteroids shot and asteroid split. Yeah, we've got them there. Okay. This is good. This is good. For asteroids level 6 splitting. Let's run this to check. Expect standard out to contain all of true. Output. True. This is good, good, good. So we got a game. Let me back it up. Paste the link to your public GitHub repo. Submit your repo. You've done it. Once you're satisfied with your game, push it up to GitHub. Then submit the link to your project. Your link should look something like ht blah blah. GitHub.com, GitHub username repo. Am I going to do this now? I think I should. I hope you've enjoyed this project. It's always good to solidify the things you learn in courses by getting your hands dirty, building something real. Extending the project. You've done all the required steps, but if you'd like to make the game your own, here are some ideas. What do I have in the read? What do I have in my README? Nothing. Absolute nothing. What all do we have here? Interesting that PyCache is already ignored, I guess. I guess UV took care of that by automatically adding it to the .getignore. So that's good. You've done all the required steps, but if you'd like to make the game your own, here are some ideas. I don't want to do NeoVim with Markdown right now because NeoVim has some Markdown tools that I sometimes find overbearing or unintuitive. So let's just vim readme.markdown. What was this thing called? It's like build asteroids with something. Build asteroids using made following the Boot.dev course. Extending the project. You've done all the required steps, but if you'd like to make the game your own, here's some ideas. Add a scoring system, implement multiple lives and respawning, add an explosion effect for the asteroids, add acceleration to the player movement, make the objects wrap around the screen instead of disappearing, add background image, create a different weapon types. Oh, cool. Make the asteroid lumpy instead of perfectly round. Make the ship have a triangular hitbox instead of a circular one. Add a shield power up. Add a speed power up. Add bombs that can be dropped. I mean, yeah, sure. But actually, you know what? I actually want to. Can I, like, How confident am I in pushing this to GitHub without leaking a token? Pretty confident. Got what? Is there a share button for this? There is. I could, maybe I'll do that. I'll take a drink of water first. You know what? Let's oops. Let's share a link to this YouTube stream in the README, right? Yeah, let's do that. I'm actually going to open a new thing here. Okay, that's actually fine. Watch an archived YouTube stream following the course here. YouTube.com. Is that how I want to do it? Probably. Add link to YouTube stream, yes. Then let's make ourselves a, and I don't want to. So after the stream ends, I will, no, let's do it now. Let's do it now. Is there a maybe I can do this from the command line? You know what? because I'm not that confident, I'm going to do it off stream. GitHub repo create asteroids. It doesn't like that. Name flags. Public, private, or internal required when not running interactively. Okay. Can I put public there? Now I think I can do the normal things. Oh, yeah, right. Get remote add origin. And now if we get remote.v, we have things. And if we get push origin main, there we go. Although, kind of want to clean this up. Maybe should have done that before I pushed it. Whatever. Let's add rough for cleaning up. Now can I just rough? Format. Run the rough formatter on the given files or directories. Let's see what changes it made. What did it change here? Second AC.velocity. Maybe I don't love that the commits will be less descriptive because of... Like I should have used rough from the start if I wanted it to be tidy in this way. Interesting that it shows this less than or equal to character. Also interesting that it didn't actually change that much. Okay, imports are going to be changed quite a bit. That's enough. You know what? Fetch C. We'll put this on a rough bench for now. I'm not sure that I want the main repo to have these cleanups in it. Is there a way to remove things? Yeah, remove. Oops, UV remove, just rough like this. Okay, if I do UV sync, okay, there we go. That's interesting. Right, so now watch an archived YouTube stream find the course here. So now we copied the GitHub link. I don't feel great about my long GitHub username, but oh well. Repository exists and is public. Yes. You've completed the build Asteroids using Python and Pygame course. Yeah, I wanted it to show that on the stream. I did want it to show that. 14.91 members, percent of members. We're at levels. Are we level 75 before the? Huh. Neat. I have one piece of feedback. It seems to me that UV run auto magically created a hidden virtual environment separate from the one I created in, was it .venv? It seemed to me that UV run automatically created a hidden virtual environment separate from the one I created in venv. Created and used a... You know what? Let's test this while we're at it. Let's just rm rf.venv. And now if we try python main.py, that should fail, right? Oh, this is interesting. Oh, deactivate. That's, yeah. PyEnv version 3.13 is not installed. Okay, so the important part is it didn't work. It's not that important why it didn't work. Is it UV run main.py? Is that all it was? Oh, interesting. Huh. So Anyway, it was unclear to me whether UV run main was using the local env or not. I was suspicious because the initial call to UV run main by took a did not. Why would that take so long if the virtual environment was already there and I had already installed Pygame, right? Why would that? Also, why is this so far behind? Huh. Okay. Anyway. Skip for now. Course complete. Thanks for watching. Let's echo goodbye Pygame. Yes. Okay. Goodbye, YouTube.